Let's continue with 7.2 and the normal distribution. So, if you have something that's normally distributed, you can use the calculator to find the probability between the values of A and B. So this is kind of the same format that we had when it was a uniform distribution where the equation was much easier. The way to do this, you're going to push second and then the vars key. That'll get you to where the distributions live. The second one, normal CDF, is the one that you're interested in. You have to enter in values of A and then B to tell it how low you want to go, tell it how high you want to go, then tell it the mean of the distribution, and then tell it the standard deviation of the distribution. In the event that they only give you one end or the other, like if you only have B, then you would have to use negative infinity for the value of A. Now, since we can't type in negative infinity, we'll just type in negative and a really huge number. Similarly, if they only give us A, we'll just do, instead of infinity, we'll just type in a really, really huge number as kind of a stand-in for infinity. So the kth percentile, so like if you want the 80th percentile, that's 0.80. And so you can calculate it also in the second vars menu for the distributions. So kind of like, again, what we saw with the uniform distribution, if you know the percentile, you're going to work backwards and find the value that will give you that probability. The function to do that is inverse normal. You have to type in the percentile, k over 100. So again, 80th percentile is 80 over 100. Tell it the mean, tell it the standard deviation, and then have the calculator do its magic. It'll tell you what you're looking for. So here, the height of an adult male is approximately normal. The mean is 69.3. The standard deviation is 2.8. So that means that mu is 69.3. That's the mean. The standard deviation, sigma, that is 2.8. And let's try to make that look more like a sigma and less like a 6. There we go. Okay, so we want something that's more than 69.3 inches. So how you would do this on the calculator, you see where it says distr for distributions. So we're going to do second vars. Normal CDF is the one that we're after. Let's see, we want it to be more than 69.3. So the lowest it's going to be is 69.3. The highest it's going to be, they don't give us an upper limit, so we'll just put a really huge number. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. That should be plenty. The mean is 69.3. The sigma is, what was that, 2.8? Yes, 2.8. So then we go ahead and we work this out. And so that essentially rounds off to 50%, which makes sense because one of the things we said last time, the answer is actually already typed there for you. If you're doing above the mean is 50% of the data, below the mean is 50% of the data. So that gives us this. So here you want you want less than 66 inches. So like the way you do that, you go to second vars, again, do the normal CDF. You want less than 66. So we're going to go down as low as we can possibly go, and then up as high as 66. Mean and standard deviation are the same. You work that out, you get 0.1193. So that's this answer right here. Greater than 72, so that means we want to be 72 or above. So again, we'll go to second vars, pick the normal CDF. So we want to be 72 or above. So 72 is the low end. Above, so we're going to go as high as infinity. So we're just going to put a really, really huge number in for that. Again, we've got the same mean, the same standard deviation. That stuff hasn't changed. So I'm going to go ahead and work that out. That's 1675. That is not what I wanted to. Here we go. 1675. All right, between 66.5 and 72.1. All right, so let's try this. Second vars. Pick your normal CDF. Let's see. What was that? That's 66.5. 66.5. That's the low end. The high end is going to be 72.1. So we do that. You get 6827. So again, all these are already typed out for us. 66 and 78. So you do second vars. Pick the normal CDF. 66, 78. Double check, that is what that said. Yes, 66 to 78. And that's 8798 if you round that off. So, hey, what do you know? Those all match. All right, find the 90th percentile. So if they give you a percentile to start with, that means you're going to use the inverse norm function. And so the 90th percentile, if it's 90th, you do 90 divided by 100. That will give you 0.9 or 0.90. So that's where this 0.90 comes from. So we go to second vars. That's where all the distributions live. Inverse normal is right underneath what we were just talking about. So the area we want is 0.9. What was the mean? 69.3. And the standard deviation was 2.8. The same as the previous example. So you work that out, and that tells you that 72.89, which is right there, 72.89 inches, that's the cutoff for the 90th percentile of height. So basically, if someone is 72 inches is 6 feet, that's roughly 6'1", which happens to be as tall as I am. How about that? I'm in the 90th percentile of height, which means I am taller than 90% of the population of men in the US. Let's see, 99th percentile. This time we do 0.99. Second vars, pick the inverse norm. 0.99 is the 99th percentile. There's the mean, there's the standard deviation. That tells you 75.81. So 75.81 inches is the cutoff for the 99th percentile. Here they say, what range contains the middle 90% of all adults in the US? So the middle 90%, let's draw kind of a very crude sketch of what that will look like. So we want the middle 90%. So if that's 90%, that means that this part on the bottom end and that part on the top end, those must account for 10%. There's 100% total. The leftover 10% that we have not yet made use of has to be split between this bottom end and this top end. And then fun fact about the normal curve is perfectly symmetric. So that means that these have to be divided evenly by 2, which means that 5% is on the top half, 5% is on the bottom half. So this from 0 up to there, that is the 5% mark, because the bottom is 0. So you go up to 5, that's 5%. Add 90 to that, because you're going up, get the middle 90% of the data, that's 95%. Or if you think of it this way, the top end is 100, back up by 5%, that's 95. So for here, we're doing this in 2 stages. We're calculating the inverse norm for 5%. That's going to give you 64.69. Do that all over again for 95%, and that's going to give you 73.9 or 73.91, it looks like. So then that means the middle 90% of all males are going to be between this height and that height. So in terms of raw numbers rather than percentages, this one right here is 64.69. That's for this specific example. And then this is 73.91. That gives you a range of heights that capture most, not quite all, most of the outcomes that you will see. All right. A certain standardized test has scores that range from 0 to 100. Decimal scores are possible, which is just another way of saying that it's continuous. Assume the scores are normally distributed with a mean of 65 and the standard deviation is 8. So we have a mean of 65. We have a standard deviation of 8. So you notice here we're going from 0 to 100. So let's see here. So we're going to do the proportion of students who have a score less than 70. Okay, so what we're going to do is we're going to do second vars, doing normal CDF here. We want to score less than 70, so we want to go as low as we possibly can, which is actually going to be 0 in this case. Although really we're supposed to go to negative infinity. And really the decimals involved, it's not going to make a humongous difference. So we'll just again do negative infinity. We're only going as high as 70. 65 was the mean. The standard deviation was 8. So we're going from, we want scores less than 70. So we're going to go from negative infinity or negative a huge number up to 70. If you work that out, you get 0.7340. Why do I keep clicking on my calendar? That is, okay, 0.7340. So that is that one. What proportion of students receive a score greater than 70? All right, so if you want to be greater than 70, second vars, do your normal CDF here. So 70 is now as low as we go, and then we're going to go as high as infinity or some redonkulously huge number. So we go ahead and do this, and we see that that is 0.26560 if you round that off. 0.26. What was that? Why do I keep going to the 0.2660 is what that is. 0.2660. There we go. There's that. What proportion of students are between 60 and 80? That's a great question. So let's do second bars. Do the normal CDF. We're going as low as 60. We are going as high as 80. The mean and the standard deviation haven't changed. They're still 65 and 8. That's 0.7036. All right, there you go. 0.7036. How about that? What proportion are between 65 and 75? So we're going to go second vars. Do the normal CDF here. What was it they said? 65 to 75. Okay, we can do that. 65, 75. 0.3944 if you round that off. All right, so that is that probability. Next, they want the 80th percentile. Okay, so then if you want the 80th percentile, we're going to need to do inverse norm to work backwards. So the percentile is 0.80 for the 80th percentile. 65 was the mean. 8 is the standard deviation. You work this out and you get 71.73. 71.73. All right, what's the 95th percentile? Well, wouldn't you like to know? Second vars. Pick inverse normal. This time we've got 0.95. This is the score that's above 95% of the students who take it. 78.16. All right, there you go. 78.16. All right, good times. Find the range of constituents in the middle 80%. All right, so let's think about what the middle 80% looks like. So this part is 80, which means this together with this makes up the other 20. So that means that there's 10 down here and there's 10 up here. If you go up 10 from 0, this is the 10% mark. If you go back from 100 by 10, that's going to give you 90. So then you're talking about the range from 10 to 90. Fun fact, 90 and 10 are 80 percentage points apart. Imagine that. So we're going to do the inverse norm. We need to find out what it is for 0.10, 65, and 8. And then we're going to do that once more with feeling. We're going to do the inverse normal of 0.90. And do that for 65 and 8. And let's work out what those are, shall we? So we're going to do second vars, pick inverse normal. Do this once for 0.10. That is 54.75. And then we do that again, second vars, pick inverse normal. This time we pick 0.90 or 0.9. They're really the same. That is 75.25. Okay, so the range of scores is this number to that number. Middle 95%, that's going to be something very similar here. So the middle 95% is going to be right there. That means that this, together with this, consists of 5%. If you cut that in half, that is 2.5%. So then this value is 2.5%. As a decimal, that is 0.025. If you do 100 and subtract 2.5, you will get 97.5% or 0.975. And so we'll do something very similar to what we just did. Second vars, go to the inverse normal, start with 0.025, which will give me 49.32. So that's the low end. And then that's going to go as high as second vars, inverse normal, 0.975. That's going to give you 80.66. So then that would be the range for the middle 95% of the data. In a sample of 200 exams, how many scores would you expect to be greater than 70? Hint, use your result from part B. All right, so part B was 0.2660. So the probability was 0.2660. If we have 200 students take this exam, then we just need to multiply 0.266 times 200. If you do that, you get 53.2. All right, so roughly 53 students, because you're not going to have 0.2 of a student, so you're going to have basically 53 students. What's the probability that 50 or fewer score bigger than that? Okay, so we want the probability that 50 or fewer. All right, so 50 out of 200. 50 out of 200 is 0.25. So 0.25 of the students are going to, that's going to be 50 or below. So basically 25% of the test takers, that's 25% of the test takers is 50 or fewer of the students. And so then we want to find out how many of them will be greater than 70. So this is basically a conditional probability. So given we are looking at 0.2660 of all the students, we're finding the proportion of 0.25 of them that meet that criteria. So that's 0.94. So there's basically a 94% chance that you'll get 50 or fewer students. So that's pretty likely. The actual number you're expecting is 53, so to get 50 or below is pretty likely for that. All right, I'm going to have to stop the video there, but we'll do the last chunk of this chapter in our last video and finish up section 7.2 then.